In this video, I'll explain what is Jordan canonical form and how to find the Jordan canonical form of given matrix. See the definition. Jordan canonical form of a linear operator or the matrix associated with the linear operator is a block diagonal matrix with Jordan blocks along the diagonal. The rest all elements 0. The diagonal elements are the Jordan blocks. So therefore, you should know what is Jordan block. For any eigenvalue lambda, the Jordan block of that eigenvalue is the one which consists of lambdas on the diagonal and ones above the diagonal, which can also be called as super diagonal, and zeros elsewhere. Then such a block matrix is called as a Jordan block. Say for example, if lambda is an eigenvalue with multiplicity 3, then Jordan block of that eigenvalue lambda is given by lambda along the diagonal and 1 above the diagonal, zeros elsewhere. So this is called as super diagonal. This is the diagonal. This is for an eigenvalue lambda with multiplicity 3. Similarly, Jordan blocks of lambda with multiplicity 2 is given by lambda 1 0 lambda, and with multiplicity 1 is given by just 1 by 1 block, that is lambda. So this is how to write the Jordan block. Once you know how to write the Jordan block, then Jordan canonical form means combination of these Jordan block based on the given characteristic polynomial and minimal polynomial of the given matrix. So, order of the Jordan canonical form is the degree of the characteristic polynomial. This one thing you have to remember. Number of rows in any Jordan canonical form is always equal to the degree of the characteristic polynomial. Now let us see how to write the Jordan canonical form of given matrix. Now here is a question. Write the Jordan canonical form of an operator T whose characteristic and minimal polynomials are given by, this is the characteristic polynomial, and m of t is the minimal polynomial. So while writing Jordan canonical form, first you have to get the order of that Jordan canonical form. Degree of delta of t characteristic polynomial is given by 4 plus 3, that is equal to 7. That is the order of Jordan canonical form. Means there should be 7 rows and 7 columns in Jordan canonical form. Now you write down what are the eigenvalues of the given operator. Eigenvalues are here 2 and 5. 2 is an eigenvalue with multiplicity 4 and this is an eigenvalue with multiplicity 3. You have to form the Jordan blocks corresponding to the eigenvalue 2 and eigenvalue 5. Let us do that one by one. Look at the factor t minus 2 in the minimal polynomial. So, the index of the factor t minus 2 in the minimal polynomial is 2. Index means power. Therefore, any Jordan block, if you write for an eigenvalue 2, then it should be of order less than or equal to 2. Next is order of Jordan block for eigenvalue 5 is that should be less than or equal to 3, because this is index of the, always you have to check the index of the factor in the minimal polynomial. Here it is 3, here it is 2. Now first write the Jordan block for eigenvalue 2 with order 2, that is 2 1 0 2. Diagonal elements are 2 and above the diagonal 1. Similarly, Jordan block for eigenvalue 5 with order 3 is written as a 5 1 0 0 5 1 0 0 5. Why I am writing these two first? Because these two must be there in the Jordan canonical form. In the Jordan canonical form, 1 2 3 4 5, 5 rows over. But Jordan canonical form must be of order 7. There should be 7 rows. Therefore, 2 more rows have to be added. Now, how to add those 2 more rows in the Jordan canonical form? We don't need to add one more Jordan block corresponding to the eigenvalue 5, because their index is same in both polynomials. But look at the linear factor t minus 2, its index in the minimal polynomial is 2, its index in the characteristic polynomial is 4. That means there is a difference. Hence, you can add Jordan block corresponding to the eigenvalue 2. While adding the Jordan blocks corresponding to the eigenvalue 2, you have to keep this in mind. Order of the Jordan block must be less than or equal to 2. Now, I want 2 more rows. Therefore, possibility is either 2, 1, 0, 2, you can add this Jordan block, or else you can add Jordan blocks of order 1. 2 Jordan blocks of order 1 you can do. Therefore, your Jordan canonical form equal to, it's a diagonal matrix. So these two blocks are must 510051005. Now you can add either this 2102. This is one Jordan canonical form. There is no unique Jordan canonical form, or else one more way of representing the Jordan canonical form is 2102. These two are must. Now 005. You can add 2 and 2. So these are the blocks. Now let me give one more example to understand this in better way. So write Jordan canonical form of linear operator T with the characteristic polynomial and minimal polynomial. The different choices for minimal polynomial given here. So let us do it one by one to understand how the Jordan canonical form has to be written. See the characteristic polynomial, first one. So I need the order of the Jordan canonical form. So order of Jordan canonical form is equal to the degree of the characteristic polynomial. That is T3 plus 2, which is equal to 5. Therefore, there must be 5 rows in Jordan canonical form. Next, you write the eigenvalues. Eigenvalues are 2 and 5. Here with the multiplicity 3 and here with the multiplicity 2. Now look at the minimal polynomial because we want to write the Jordan blocks. Now see here the linear factor t minus 2, its index is 2. Therefore, there must be Jordan block of order 2 corresponding to the eigenvalue 2. And here the index of t minus 5 is 1. Therefore, first you have to write the Jordan block corresponding to the eigenvalue 5 with the order 1. So let us write that. So with order 2 means 2, 1, 0, 2. Then with order 1 means it is just 5. Here they constitute totally 3 rows of the Jordan canonical form. So 2 more rows I need because it is of order 5. Look at the index of the linear factors in the minimal polynomial and in the characteristic polynomial. Here t minus 5 index is 1. In this case index is 2. Means it differs by 1. I need to add one more Jordan block corresponding to the eigenvalue 5. But its order should not be more than 1. So one more eigen block of order 1 only I can add, so that it compensates with that of the index of characteristic polynomial. Similarly, t minus 2 whole square here it is whole cube. So one more Jordan block corresponding to the eigenvalue 2 I have to add, but its order should not exceed the index of the t minus 2 in the minimal polynomial. Now index is 2, either you can add Jordan block of order 2 or order 1. So already 4 rows are formed. Therefore, I need one more Jordan block corresponding to the eigenvalue 2 of order 1. Therefore, your Jordan canonical form of the given operator with this characteristic polynomial and minimal polynomial is given by, I can just write diagonal because diagonal matrix with the diagonal blocks as 5, then 5 and 2. Or else you can write the diagonal matrix also. See, Jordan canonical form not unique because you can place these diagonal blocks anywhere. Now see the second one, delta of t. This is the characteristic polynomial and this is the minimal polynomial. So look at the index of t minus 2 in the minimal polynomial and t minus 5 in the minimal polynomial. Both are of index 1. Therefore, first form Jordan block of order 1 corresponding to 2 and Jordan block of order 1 corresponding to eigenvalue 5. Now, these two are must. Now, other than these two, compare the factor t minus 2's index in the minimal polynomial and in the characteristic polynomial. Here it is of order 1, here it is of order 3. Therefore, here the difference is 2, t minus 2 whole cube, t minus 2 whole power 1. Therefore, you have to add Jordan block corresponding to the eigenvalue 2. I can't add Jordan block of order 2 because its power is 1. You can add Jordan block corresponding to the eigenvalue 2 of order equal to 1 or less than 1. Less than 1 anyway not possible. Therefore, I have to add Jordan block of order 1. So I have to add 2 such Jordan blocks because here the power differs by 2. I need 2 such Jordan blocks. I can't write 2102, which is not possible because here the index is 1. Similarly, t minus 5 to the power 1, here t minus 5 whole square, they differ by 1. Therefore, I need one more Jordan block of order 1 corresponding to the eigenvalue 5. I can't add 2 Jordan blocks corresponding to the eigenvalue 5 of order 1 because they differ only by 1. Therefore, 1 is enough. Here I need to add 2. Therefore, Jordan canonical form is given by diagonal matrix. Here 2, 5, 2, 2 and 5. All diagonal blocks are 1 by 1 blocks. See the third one. Here this is the characteristic polynomial and this is the minimal polynomial. It is of index 3 and here it is of index 2. So first write Jordan block corresponding to the eigenvalue 2 of order 3, which is 2, 1, 0, 0, 2, 1, 0, 0, 2. Now Jordan blocks corresponding to the eigenvalue 5 of order 2, it is 5, 1, 0, 5. See, both the factors are of same index in characteristic polynomial and minimal polynomial. Nothing to add more here. These only constitute 5 rows of the Jordan canonical form. Therefore, Jordan canonical form directly written as diagonal matrix with the diagonal blocks as 0, 2, 1, 0, 0, 2 and 5, 1, 0, 5. See here, determine all possible Jordan canonical forms for a linear operator with this as the characteristic polynomial and this as the minimal polynomial. Here, the order of Jordan canonical form must be equal to the degree of the characteristic polynomial. That is nothing but 5. There should be 5 rows in Jordan canonical form. And all eigenvalues are equal to 2. Hence, all diagonal elements are equal to 2. It is very simple here because it has only one eigenvalue. So, eigenvalue is just 2. Now, I have to form the Jordan blocks. T minus 2 to the power 2. Index is 2. Therefore, there must be one Jordan block of order 2 in the Jordan canonical form. That is given by 2, 1, 0, 2. Any other blocks if you are adding, then those blocks must be of order 2 or less than 2. Hence, Jordan canonical form is equal to diagonal matrix with this block compulsorily. Then I need 3 more rows because the order is 5. I can add 2, 1, 0, 2 and 1 just 2. Jordan block of order 1, here Jordan block of order 2. This is one possibility because together it gives you 5 rows. Or else another possibility is diagonal 2, 1, 0, 2. Then instead of this, I can add a Jordan block with order less than 2, that is order 1. If you choose order 1, then you have to add 3 such blocks. Together gives you order 5. So this is how we find the Jordan canonical form for the given characteristic polynomial and the minimal polynomial.